So, with all those administrative matters out of the way, let me basically spend the remainder of the time on the thing that's basically me playing with the ChatGPT, but our version of ChatGPT, which has some additional course-specific content and also some system instructions, which at this point is really long overdue for fixing. One thing I'm really looking forward to fixing is making it go through multi-part questions, one part at a time. I think that ought to be a fairly easy fix. Some of the other things that I want to accomplish with a more interactive tutoring session that might be a little bit harder, but I'll try some different things over the weekend, and I'll when I think it's at least not any worse than it is now, then I will, and publish, and it'll basically be at the same link. It'll just be a newer version of ChatGPT and or CoA Physics GPT. So for today, it'll be the old version. So some of the questions as I ask, it'll be doing the same thing that it was doing before. Not basically not being as interactive as I wish it were. And if a question has multiple parts, it'll answer them all. One thing I can do, I can give it one part at a time. So I can at least, kind of simulate for myself, will it be acting fine if, except for that it's current failing that it approaches multi-part questions just all at once. Let me just, I can give it just one part at a time so that it doesn't answer part C while I'm still ostensibly stuck in part A. So, with that, let me start. So, I'll just take a few questions. Like, this is probably, so 0 and 5 potential. Is this? I'm wondering if. So I think I can make some minor mistake for part A, and kind of a plausible mistake. Like well, you guys might not have as much familiarity with these materials as I do, but you're all smart people. There has to be some degree of realism to the kind of mistakes that that you guys might make. So here, let's say with all these portions of text, question text reminding you, you remember enough of what you read in the textbook, what you saw in the lecture, so you remember the form of the potential for point charge. And here, they are point charges. They're not even spherical thing. So you remember the formula for point charge as a function of R equals as Coulomb constant charge over R. I think there's a minus sign. No minus sign because that's for gravity. And if it's attractive, the negative sign of charge would handle that. And you also remember the relationship between potential energy and electric potential. Potential energy is the test charge times the electric potential. So for the potential energy of Q2, you so I guess so you write down an expression that looks like a Coulomb constant times the amount of charges. So Q2 and it's at that distance, so you just do Q1 times Q2 divided by R, and you plug in all the numbers. And let me make the mistake that I was gonna make. So I guess, so for this mistake to be plausible, I can't be using, although I could use Wolfram alpha. So let me use Wolfram alpha this way. I'm going to make a power of 10 mistake, which is very plausible and possible when you are ignoring the metric prefixes. So let me do it that way. And sometimes you get an answer in scientific notation, and sometimes people just forget the power of 10 that comes up. So here I could be doing Coulomb constant times the charge 5 Coulomb. I forgot about the microcoulomb times the 9 Coulomb, and let's say I correctly ignore the mass for now, divided by the distance 3 centimeter. That should give me an answer in joules. Yeah, so you have joules, but you forget and you say 1.348. I guess it's probably not overly plausible. Because I think once you see that it has deducted a point, then I think most of you will then at least know to look for, did I miss power of 10? And maybe you did even check for that and you put in, power of 10 E13. Here that won't actually fix it because my mistake goes farther back. I missed the micro part of it. So let me give this to ChatGPT and see if it can help me figure out what I did wrong. I'm hiding a portion of the information from it in that I didn't give it the input part where you can see that micro part missing. Let's just try this out. I'm working on my physics 4B homework and I'm stuck on part A here. I think I have all the formulas, and at first I missed that 10 to the 13, and so I got one attempt wrong, but it still says my answer is wrong after I correctly included the power of 10 in E notation. Can you help? And this is the kind of thing that if you are working with a good tutor, so they would see the expressions and they would probably try plugging in numbers themselves, and after having plug the numbers themselves, they will notice that this portion of the number you are right, this portion it's wrong, and then they might try to guess what mistake could you have made. And I don't know if it's all that easy to figure out if you just miss the micro part of it, but somehow I got the centimeter part of it. So let's see. Right at part A, yeah. Crunching anything. What have you tried? Units on the charges and the distance first. And I guess as you are reading this, then you might realize that, I put in 5 Coulomb. Product division. What? Magnitude on the tens of joules, not that. Yeah, that huge number means yeah. So yeah, that yeah. Oh, I missed the micro part of UC. So let's put that in. Then it should be correct. And for part to be yeah. So yeah. So 1.348 E1. Okay, I got that part of the question correct. This question has a part B, and I'm not sure what I'm doing wrong. So I'm gonna do really very simplistic thing, which is taking this expression, take it as your energy, your kinetic energy, and calculate. So set this equal to 1/2 mv squared, and calculate V is equal to square root of 2 times that divided by mass. So let me do that on a calculator. So V is equal to 2 times that, 2 times 13.48 divided by the mass, and this time I do the conversion, to kilograms, 0.0065, and I have to take square root of that. So you get this answer. You thought you probably did it correctly, and then it says it's wrong, and you are stuck. So let me now ask, my got the part correct? This question and what I'm doing wrong. I solved for free Q2 using the given mass information in the question, and it says it's wrong. I checked. I'll just leave it there. I was considering whether to ask, am I making power of 10 mistake again? But I don't think ChatGPT is confused by red herrings like those. At least I haven't ever seen it work. Like, I make a suggestion like that and it never takes it up. So I'm pretty sure adding that bit doesn't test anything because it never gets confused by that. I don't know if we'll figure out what my mistake was from this answer alone. Basically, my mistake is, I'm treating it as if this is the answer it would be if I'm looking for when it's out at infinity, because that's basically the potential energy difference I'm using from here to infinity. I had to stop it at 7.6 centimeter. I don't know if it's gonna figure that out from the numerical value of my answer, but it'll probably tell you the correct steps. And this being a relatively simple question, other than pointing out that mistake, I don't know how much more. Using reference, get it from lecture. Oh yeah, I do like. So this is coming from the lecture. I think I'm the only one who refers to that as a universal reference. It's not some standard terminology. It might be. Yeah. So setting it up like this is how you should do it. Work with a snapshot, like initial snapshot, final snapshot, and like when you set it up that way, one of the benefit of that is like it's less likely for you to miss details like this, because that's what I missed. Common solids. Oh no. Yeah. Maybe what number do you get for the bracket if it's around? Okay, I guess. So it's giving me some intermediate step. I don't know if I don't know. It's kind of done the whole thing for me here. I don't know if I necessarily like that. Let me see. Sorry, that looks like a lot of info. Can you just help me figure out why my answer 64.40 meter isn't right? So I'm role playing someone who just started to sing this wall of text and then just said, "All right, I'm not reading all that. Just help me with my help me with my stuff, because I probably got most of it right." And I think that's what a good tutor should do. Like, the things that you already know. Like, if it looks like I already know, like the fact that you should use conservation of energy, then there's no value in tutor repeating it. Now, but figuring like reverse engineering a mistake made, that can be challenging. Like sometimes I try and I don't always get it. That's one of the reasons on the problem set assessment I ask you to attach your work, because with your work attached, it's easier for me to figure it out. Uh, if I I have exposed. Uh, that's an unlikely mistake. Like why would I plug that in? Looking over there, yeah. So it's maybe we won't ever get it. So I'll say, yeah. All right. 50 is correct. I'll just ask my instructor later why my 64.40 meters wasn't correct. I didn't use a different mass value. I've seen ChatGPT guess that as a mistake before, and I don't think that's a like who would do that. I mean, it's one thing if it's similar to the number you have, but like you're not gonna just pick another random value of mass. Okay, so let me go pick a more substantial question. This was question 1. Usually, not all that substantial. Let me see here. Let's see. Maybe that previous question is a good one to try, because electric field between two large conducting plates. Yeah. So here is where I can imagine someone who's formula hunting could kind of get stuck. As in, you remember some formulas that are related, but not relevant for this particular question. So this is actually a super easy question. Once you remember the kind of relationship between voltage and electric field and the distance, then what you should be using is really delta V is equal to minus integral of E dot dl. So if it's delta V from A to B, or I might be making sign error, something like this. That's what you should be using. Then like with a constant electric field, it becomes super easy. But let's say I remember the formulas from past week. One where we derived electric field due to a plane of charges. So this version I only have it memorized in terms of the permittivity of free space. So to express it in terms of the Coulomb constant, I have to write this first, and then imagine substituting in 1 over 4 pi ke for epsilon naught. Then I think it's 2 pi ke sigma. Probably should have memorized it at some point. So let's say you did this, you tried an answer, or I guess you can't try an answer. So what I'm going to now complain is that I don't seem to have enough information. So I might even write down sigma is equal to Q over A, but no amount of charge is given, no area is given, and I'll complain about that. Oh wait, it figured it out. Oh, okay. Why didn't it do that before? Yeah, okay. Oh, maybe because I didn't tell. I told it that I didn't use a different mass value. Once you rule out that potential mistake, then it might have figured out the other possible mistake. Yeah. It'll always have those follow questions. Make use of it. However, like if you have a lot of time and you want to make sure that you didn't just do what I did, plug in the answer and just move on without understanding, then you can follow up on this. You can also just ignore it. You can just say, I got another question. Like one of the nicest thing about generative AI is it'll never be insulted by you ignoring its questions. I got another question. I have this question about electric field of a conducting plate. I think basically an infinite plane of charges. But it doesn't look like the question gave me enough information to go on. I don't have the sigma or q. Can you help? So let's see. I guess what I'm looking for is so I guess when I said tutor, so there's a kind of that's one part. There's one part of tutoring that I was never good at, how to be tactful when someone's just wrong. So here, I think that might be what I would have done. Yeah, for two large parallel plates. Yeah, and in fact, as long as you can say that it's uniform, like they didn't have to tell you that it's like a parallel conducting plates. Although that makes the setup easier because then there's a potential difference to specify. It could have been like a single plate. You have someone could just specify potential difference between two different positions in space. But yeah, this is the expression that you are using. I think that it shouldn't do that. Just giving you the answer. Yeah. That's it on my to-do list for the update this weekend. I I have to try out a few different system instructions. Basically, I think it should never tell you the final answer like on the first response. And here, basically, I think it should have. I think it should have stopped it here. It pointed out your mistake, um, and then it kind of told you the right formula, right relationship to use. That's where it should have stopped. Uh, so, tiny check for you. If we double the spacing, oh yeah, I guess I can answer that. But at the same voltage, what would it become? Hint: delta V is fixed. Um, so it would be half the, right? Yeah, let me say that and then see what it says. And then after that, I'm gonna pretend to be confused. Um, so if the so this is how I'm gonna be pretend to be confused. Uh, but you said the delta V is fixed, meaning the power, the battery, meaning the battery voltage source is still attached. That means the amount of charge on the plate is constant, right? Uh, that confuses me because the formula I had before, I get that I don't need Q or sigma for this question, but I want to make sense of the setup for myself. Formula I had before would have electric field staying the same if the charge didn't change. And this is, by the way, the kind of the common two different constraints. If delta V is the same, Q actually has to change. here, if you're pulling them apart, I think a Q actually goes back into the voltage source. Yeah, two different experimental setups. So delta V fixed, then that actually makes the Q change as the capacitance changes. Yeah. And this readjustment can happen in either direction, either more charge flowing out of the battery or some of the charge flowing back into the battery, which for non-rechargeable battery, who knows exactly how it goes. The whole thing has net charge 0 anyway, so disconnected the battery. Then in this setup, this actually increases. And what that increase in delta V reflects is so as you pull it apart, you have to do work to pull it apart, and the work you're doing basically goes into potential energy of the stored in the separation of the plates. Removed after charging to new delta V. So here, let's say, I think it would have to be the same to conserve energy, since the battery is now disconnected. This is the last time I'll pretend to be confused. And then hopefully they'll explain the work that you are doing to pull them apart actually changes the energy stored in the capacitor. As it's answering, let me go look for another question to ask. Maybe a more substantive one. This might be the last question I ask. The integral, don't know if that's all that interesting. Think about energy. Yeah, I get that, but does it get at energies increases? Yeah, mechanical work you do. Yeah, that's the standard explanation. Energy is conserved just fine. Energy of the universe. You did the work to put more energy into the capacitor. So let me see. Two large charged plates of charge density face each other. I could ask this. Let me see if there's another one that's not so much, rectangular geometry. Capacitor questions. Is there nothing spherical in this set? It might be just my luck. Let me see. So, with this group of 2 questions total. Wait, there are 5 questions in this post, so this probably doesn't. 2 questions for parallel plate. Infinitely long wire. They are probably all using this the linear geometry. For this question, there are charged plates. It's possible that the other question on that is the that's the spherical geometry. So let me do this. I'm just gonna make an attempt so that this button pops up. Let me get a similar question. Yeah. So there is a question that involves the spherical geometry. It's just one of the 2. Let's see here. So this is let's see, what can I ask? So one of the things I do want to get to is so here's where I've seen people make a mistake. People might put 0 here because electric field inside the sphere is 0, but inside the inner sphere, is 0. and you might also electric field outside the outer sphere is also zero. I think the way it's set up, yeah. So you might get this as 0, and then you might also see, oh, look ahead, yeah, that should also be 0, and that won't be quite right. And the fact that you got one right and one wrong, maybe that confuses you and you want it explained. So let's see. I think I just have to do this as 2 screenshots. There's no good way to include everything in one screenshot. And let me not include the BNC so it doesn't answer. So okay, I have a new question. For this question, I got a right reasoning that since E is 0 outside, I have delta V equals minus E D equal to 0. I thought I could apply the same reasoning to part D, second screenshot attached, but it says it's wrong. What am I doing wrong? Will it answer the whole thing? So I guess if I were getting this question as like an online tutor, I might ask for what are parts of B and C, because answering parts of B and C could help you kind of build all the parts you need to answer part D right. But I would probably explain that the electric field 0 being 0 just means the derivative of voltage is 0. So you can still have a like constant offset. And to figure out the constant offset, you kind of need to know what's the change in potential energy that's change in electric potential that's occurring in this in-between region. Yeah. Oh, I could have answered this too. That's also 0. So like immediately outside the wall is 0. Immediately like this conducting shell is 0. So it's really this part, electric potential of the sphere. That's what you need to figure out. Go 0 to, yeah. I don't know if it's classic, but I think I've seen people make the mistake. Yeah, inside conductor is 0. Yeah, potential is constant, not changing. But the values of so here it's 0 because you are working with a universal reference, where at infinity potential is 0. The value must, yeah, this is the key thing. In the cavity to yeah, field isn't 0 comes from, yeah. Does it work out the whole thing? Inside the solid inner sphere is a constant equivalent, yeah. Yeah, so whatever answer here is, it's gonna be the same answer here. Yeah, I need to adjust the system instruction so that it really should stop. I mean, 2 different ways it could have gone. Like it could have done this and then ask you, do you need help setting it up? And then maybe, if you say you need help, then do this rest. And or it could have told you most of this, and then left you to like up to here, and then leave it up to you to set up the actual detailed formula. So what is annual indicator? Yeah. It's not just gonna be V over R, like 1 over R thing. You have to adjust for the shell being at 0 volts. So let me put this in. Okay, 1.35 E6V was correct for D. And I figured I could still use delta v equals 0 for b as well at r, or at r between I think it's between 5 and 6, yeah, between 5 and 6 centimeters. Potential doesn't change. Is C going to be the same as D? And it'll probably say yes. Yeah, and so one of my main goals updating CoA Physics GPT this weekend is make it more interactive. Like, it gave me the insights right away. And even though it does ask a good follow-up question, my fear is that for a lot of people, like, you'll skip the follow-up question. And really the place where you should learn how to do a question like this is by attempting these steps that ChatGPT did for you. It should have given you the option to attempt it yourself first. And again, if you simply insist on an answer, it'll give it to you. Like, I don't think preventing that particular behavior is possible. But I think mainly what I should probably try to get it to do is limit the length of its responses. Like, this wall of text thing, I think it's harmful in a couple different ways. Yeah, C is same as D, yeah. With conductors, so yeah, must equal, right, yeah, which quantity? E, yeah. Thank you for the answer to your question. Neither, right? I thought discontinuities were unphysical, aren't they? So I guess it's a matter of approximation. So to the degree that you approximate a charge distribution as a infinitesimally thin surface charge, that approximation leads to discontinuous electric field. Now, if you physically model the charge as being like a slab of density of charges, where the thickness of the slab, although small, is not infinitesimally, zero thickness, then it would be continuous everywhere. But can have this continuity at a conductor's surface or any surface charge. Yeah. So it's basically so the whole idea of surface charge, it's like a point charge. It involves a degree of approximation, and the result, kind of consequence of that approximation is you are going to have apparent discontinuity, singularities at point charge, that sort of thing. And yeah, physical enough anyway. Yeah. And something like this, you will see it for those of you who go on to take physics 4C and quantum mechanics. You see something like this with like a wave function. There are some aspects of particle wave function that cannot have discontinuity. Like, value of wave function itself cannot have sharp steps, but like the first derivative can have sharp steps if you have things. Oh, let me see. Yeah. Can you show me the sketch? I had a similar question where I answered VR equals prop to 1 over R, which was graded as incorrect, and I have hard time visualizing what VR should look like for these concentric sphere distributions. don't know if it'll do it correctly. I had some issue. Guess that was last week. Trying to do some free body diagrams with a physics 4A problem, and it the kind of the diagram generation thing, it was going through what looked like a DALI, and it wasn't generating a correct diagram. So I wonder if this will do it correctly, what potential versus R looks like. It might go through a plot generation and do it correctly. So just want to see. Is it frozen? No, remain frozen. Should I open on you? Because I think the response is they're waiting for me. It's just this particular front end that's frozen. Sketch of it. There's a clean sketch. Wait. Sorry, I don't see a sketch. It's just describing it in words. PHYS function. So inside the constant, in the cavity. So this is a constant offset that kind of accounts for this outer shell being at 0 volt. Constant shift. So it's correct description, but saying it's plotted, but it's not showing. So it's some sort of an interface bug. So I see this screenshot, but clicking on it does nothing. Maybe it's supposed to display in the chat. Can you give me a file that I can download and view locally? So V itself will have a kink, like a sudden. It won't be, so it'll be continuous but not smooth. There'll be sudden change in slope. So look, is it correct? I guess that's correct. So normally there would have been like this 1/r thing would have asymptotically approached the 0, but with this setup there's an offset that allows you to basically cut it off here. From here it's just the 0, and that kind of, that I think that looks correct. Good plot. GPT's got really good at doing plots, or any diagrams it can generate like it's a plot. So I'll say I think I can imagine this. I guess I missed that constant offset part. I'll try to remember that next time. That's all for now. Thank you. So that's I think all the time I want to spend playing with the ChatGPT, and I will update again the CoA Physics GPT over this weekend with the additional material that's upcoming next week. Circuits and magnetostatics, and while I'm doing that, I'll also update some of the system instructions, trying to address the issues I've seen in the last couple weeks, and we'll see. I do have to get better at prompting, because it's like if it's a programming language, I know what to do, but it's so I remember hearing the word prompt engineering like a couple years ago when ChatGPT first came out, and I thought it was a joke, but it's the kind of thing where I wish there was like some theory to prompt like prompt engineering. Because at the moment right now with the system instructions, I'm basically trying things out at random, and then so that's why I keep saying over the weekend, because I think I need to give myself a good half a day to try out different things, and I'll basically whatever behaves best after a few hours trying, I'll publish that. And so the update will probably happen sometime on Sunday evening. And if you are using CoA Physics GPT at the time, its behavior might suddenly change. To let me know if anything's if there are any serious issues, then I can revert. So one of the reasons I started keeping track of my system instructions that I've used or that I am currently using, and because this is Google Doc, it does its own like a version control. So the reason I started doing it this way was so that if any particular change does a thing that it's not supposed to, then I can revert it pretty easily. So when I update it over this weekend, if it does anything that's making it not as useful, do let me know, and I can either revert it or fix it or something. So all right. Thanks so much to those of you joining this session to the end, and thank you to those of you who are here in real time. And let me say goodbye to people joining by recorded the video, and I will stay online briefly in case people who are here in real time had any questions that they didn't want to ask on recording. So bye to people joining by recorded the video.